Friday we graphed, right? To solve our, I think I can even go back and manage to save it. We graphed. We looked at for the intersection point. We have an ordered pair as an answer, right? And then we practice substitution, making sure one equation is either x equals or y equals. And once you get that, subbing it into the other equation, right? Again, our answers were ordered pairs, unless it's a special case. One last one we have to talk about today is elimination. Okay, elimination, your goal is to eliminate the variables, or eliminate one of the variables. And elimination works better, and on all of these that you're seeing on the screen right now, if both equations are in the form, which is standard form, ax plus by equals c, where you've got them lined up with x and y on one side, the number on the other side. That's traditionally how standard form works. I don't know how much you guys remember about elimination, but any thoughts on what we should eliminate?
4x.
Okay, so maybe we do remember a little bit. Okay, we can eliminate the x because they have the same number coefficient, right? They both have 4's in front of them, and even better, they have opposite signs. There's a positive 4x and a negative 4x. So in order to eliminate, these equations are already lined up. We're going to take the two equations, and we're going to add them together. So I'm just going to do that right there in my work. So we're going to add 4x and negative 4x together. Now, if we're going to add those two together, we're going to add the whole thing together, aren't we? So, what is 4x plus negative 4x? 0. It cancels, right? So when they're opposite signs, if we add them, they're going to cancel out. Okay, continue adding like terms. 2y plus 3y? 5y. Equal signs are lined up. And then 9 plus 16? 25. What do you know about 5y equals 25? Yeah, if it's 5 times y, we can divide by 5. If we divide by 5, what are we going to get?
5.
Yeah, 25 divided by 5 is 5. And so we find y to be 5. Am I done? No, we need ordered pairs, right?
Yep.
Just like on Friday, I need ordered pairs. So, well, this part was the easier part. Unlike substitution, this next part's going to be the part that's a little bit more difficult. What do I do? Where do I put this y equals 5? Okay, one of the original equations. The only thing that makes it a little less nice is that you don't have an x equals or y equals to plug it into. So it doesn't matter which one you pick. Pick whichever one looks more interesting to you to work with. I'm going to pick the top. I'm guessing you guys would too, just smaller numbers and no negative. So where it says 4x plus 2y equals 9, I'm going to say 4x plus 2 times 5 equals 9. 2 times 5 is 10. Equation solving skills, if it's 4x plus 10, how do I solve? Subtract. Yeah, if it's 4x plus 10, we're going to subtract 10. What I do on the left, I do on the right. So 4x carries down. 10 minus 10 is gone. 9 minus 10 is negative 1. And divide by 4. 4x divided by 4 is going to leave me with x equals negative 1/4 is how I would leave it. Okay, we found in the last homework there's a couple where they wouldn't let you do decimals, would they? They required it to be either an integer, so like a positive or negative whole number, or a fraction. Well, some of them were doable. Like, for instance, if you got 0.25, I would like to think that you guys know when you see 0.25 that is 1/4 as a fraction.
0.667.
Okay, that one's doable. What's 0.6 repeating? Do we not know that one?
2/3.
Okay. Well, so, and here's what I will say anytime there's one digit repeating, so 0.6666, because that's what that 0.667 was, put it over 9.
I might remember that.
Okay, well, it's learned. The one I struggled with how to instruct was when it was 0.83 repeating. So, but if you don't know that one's a harder one to instruct. So,
This 0.25 is about as far as mine goes.
okay. Did you guys write an ordered pair down?
Yeah.
Good deal. Okay. Example 2. Which variable would you like to eliminate?
The Y.
This one's set up to eliminate y's, yes, because they have the same coefficient. They're both 8y's. Now, what's different about this one, though?
It's not negative and positive.
Yeah, it's not set up automatically to where I can just add them and they cancel, because we don't have opposite signs. So there's 2 different ways I could teach this, and I have no idea what you guys were taught in Algebra 1. But, and if you don't remember, it doesn't matter, right? What I tend to teach is that we multiply one of the equations by a negative so that you can still add them. Okay? And that way we're always adding. That's one way we can look at it. The other option is you can just subtract them. Now, I don't know what you're taught in Algebra 1. I don't know what you'll find easier. But either way works. Okay? So one option is if I pick one of these and multiply by a negative, and I'm going to pick the bottom one. Okay? You could pick either or. But if I multiply that bottom one by a negative 1, my top equation stays as is. Negative 2x plus 8y equals negative 8. My bottom equation. What does multiplying by a negative do? Changes all your signs, right? So this becomes positive 5x minus 8y equals positive 20. Now, for those of you on this boat, by doing this, I now have a positive 8y and a negative 8y, right? So I can do the exact same thing I did last time, which is to add the 2 equations together. So if I add these, negative 2x plus 5x is 3x. 8y plus negative 8y cancels, equal sign. Negative 8 plus 20. 12. Now, I'm guessing a few of you tried subtracting. If you tried subtracting, you should be at the exact same location I am now. Okay? Because subtracting, you would have just done negative 2x minus negative 5x, which would give you 3x. 8y minus 8y, which cancels. Negative 8 minus negative 20, which also gives you 12. I don't care which way you do. Okay? 3x equals 12. What do? Divide by 3, and we know that x is 4. Am I done?
Yeah, put it back in.
Nope. Plug it back in. And again, pick. I would go back and pick from one of the original equations to plug it in. Which one did you guys pick? Top one. So, negative 2x is going to become negative 2 times 4 plus 8y equals negative 8. Negative 2 times 4 is negative 8 plus 8y equals negative 8. How do I solve for y? If it's negative 8, I'm going to add 8. Negative 8 plus 8, 0. There's 8y. What about negative 8 plus 8 on the right? That's 0. Now what? Divide by 8, right? So don't let that 0 throw you off. Divide by 8, and what is 0 divided by anything? 0. So we have a final answer of 4, 0. Okay. And I'm kind of working them up baby steps here. The first one, we had same coefficients, opposite signs, good to go. The second one, same coefficients, not opposite signs. What's your plan from there? Now, I'm going to my next screen for the next one. You guys have what you need from here? Next one, what would you like to eliminate now? 2x plus 7y equals 4. 3x plus 5y equals negative 5.
The Y,
Yeah, the one.
The y's?
Yeah.
Why the y's?
because the one that's on top is bigger than the one that's on bottom.
Interesting thoughts.
Yeah, I don't know.
Okay. Now, and regardless of which you pick, how do we eliminate them?
Multiply by a negative.
Oh.
I don't
Careful.
really know.
Okay. So multiplying is the key here. Because as it is right now, whether you add or subtract, x's or y's, none of them are coming out to 0, are they? So it was interesting to hear Patrick say the y's because the bigger y is on top. I would have said the x's because they'll multiply to be smaller numbers. Does it matter, honestly, in the end? No, we don't have to go the same route here. Okay? With that in mind, how do we make the x's or the y's the same?
Can I have Nora for just a quick second? Nora Conrad.
There you go. Okay. How do we make either the x's or the y's the same?
Question.
Do we remember? You guys say multiply.
Multiply by least common. Yeah, least common multiple.
That least common thing. Officially, least common multiple is the word.
Yeah.
Okay. So how can we make 2 and 3 the same? What do they both multiply into? 6. So then we can multiply by 3 and a 2. What if you want to go y's? What do 5 and 7 multiply into? 35. So then we're multiplying by 5 and 7. I'm going to go x's because they're a little bit smaller number. Now, one of those numbers, since both are positive, one of those numbers that you multiply should probably be a negative. Okay, that's going to be my recommendation there. So I'm going to suggest, let's see, if we go the x's, multiplying by 3 and multiplying by 2, I'm going to use my negative on the bottom, just because it's more like subtracting that way. So, multiplying my top by a positive 3, it becomes 6x plus 21y equals 12. Multiplying the bottom by, I'm going to do negative 2, so I change the sign. Negative 6x minus 10y equals positive 10. And I have set myself up here to add. Now, in all honesty, did you have to multiply by a negative? No. If you figured out the subtracting, you're confident in that, you could just have done positive 3 and positive 2. Okay. Add away. 6x plus negative 6x is 0. 21y plus negative 10y. 11y. 12 plus 10? 22. 11y equals 22. Divide by 11. Y is 2. And what do I do with that y equals 2?
Yeah.
Plug it in. And this is where I would go back to one of my original equations, not one of the ones I changed to, the original equations. Numbers are smaller and easier to work with. Which one did you guys use? Top one? Realize you don't have to use the top one, right? It just seems to have less negatives and nicer numbers is what we've been seeing, but pick one, either one. So 2x plus 7y, except my y is 2, equals 4. 2x plus 14 equals 4. If it's 2x plus 14, I'm going to subtract 14. 2x equals negative 10. Divide by 2, and x is negative 5. Final answer of negative 5, comma 2. Okay. Another example. We're almost there. What would you like to eliminate, x's or y's?
Ones,
Y's? How would you want to eliminate y's?
multiply them, well, multiply the 7, the top one by 2, and then multiply the bottom ones by 7.
Okay. So y's could become 14y's, yes? Okay. If you're not a fan of the y's, you could do the x's and make them both 15x's, right? They both work out, okay? I think I had planned to, because we eliminated the x's last time, I was going to eliminate y's this time. Honestly, it doesn't matter. 14x or 15x and 14y's are very similar, aren't they? Neither of them are huge numbers, so. So if we multiply the top by 2 and the bottom by 7, did you say a negative in there? I forget.
We can just do,
Let's say. I tend to do the bottom one by negative if I need a negative. Right now they're both positives, so I would multiply somebody by negative. Okay, multiply my top by positive 2. It becomes 6x plus 14y equals 30. My bottom equation multiplying by negative 7. Negative 35x minus 14y equals positive 28. And did I set myself up to add the two equations?
Yeah.
Yeah, I've got positive 14y and a minus 14y. So this is going to be an addition problem, which is what you're always going to see me lead you guys to. 6x plus negative 35x.
Negative 29.
Yep. Negative 29x. 14y plus negative 14y.
cancels,
Cancels. Carry down my equals. 30 plus 28.
58,
58. Well, what about negative 29x equals 58?
divided by 29.
Yeah. If we divide by negative 29, what just so happens? Yeah. It divides nicely. If I write the right number, and x is negative 2. Okay? Pick an equation and fill it in. I'm going to use the bottom one because I can. If you want to use the top one, use the top one. So I'm going to say 5x, so 5 times negative 2, plus 2y, equals negative 4. Negative 10 plus 2y equals negative 4. How do I move a negative 10 across the equal sign? We're going to add 10. So then I have 2y equals 6. Because negative 4 plus 10 is 6. And y is 3. Ordered pair, so xy, negative 2, comma 3. Okay. Last one. What do you want to eliminate?
X's.
Okay.
So why? Well, I mean,
We can eliminate.
Here's the deal. Is it set up for elimination already?
Yep.
Yeah, if your brain sees the x's, they're both 3 x's, and they're opposite signs, right? You have a positive and negative, so you're adding. If your brain said, nope, my brain saw the y's, they're both 1 y's, and they're opposite signs, so you're still adding.
This all just equals
Okay, so what's negative 3x plus 3x?
0.
What's y plus negative y?
0.
So what's on the left side?
0.
0. On the right, what's negative 5 plus 5?
0.
0. What happened to my variables? Okay, my variables cancel each other out, yes. When my variables cancel each other out, 2 choices. No solution or infinitely many solutions?
Infinitely.
I think no solution.
All real numbers.
Infinitely.
Does 0 equal 0?
Yeah.
Okay, so difference from the one we did on Friday is that this is a true statement. We ended up with 0 equals 0, which is a true statement, which makes this infinitely many solutions. And I haven't been back in Savas to remember what they provide you as your answer choice. Similar idea is all real numbers. I don't really think they'll use all real numbers here because it's infinitely many ordered pair options is what they're going to be saying. Okay? If this instead came up as to 0 equals 17, does 0 equal 17? No, variables cancel out. You get a false statement, then we say no solution. That happened on the front side of the notes in substitution, didn't it?
Yeah.
Okay, so you've seen an example like that, similar idea. Okay, questions?
No.
Okay. You have some work time. Use it. Okay, lesson 1-6 part 1, and then anything else you might need to catch up on.
We got our purchase list music.